Okay, so picking up again, this time with secondary storage, I pose this question to you up front. Why is it important for an organization such as yours to store data effectively and safely? I'll let that sit for just a second, and we'll go over that in a little bit, but I think the answer will become pretty clear. Secondary storage is a device or set of devices or a way of storing large amounts of data, instructions, information, etc., more permanently than we would in main memory or elsewhere, right? So your hard drive is a way to store information for a longer period of time. But there are capacity issues. So in addition to your hard drive, we also want to make sure that there's availability. You remember CIA, right? Confidentiality, integrity, availability. So we'll use RAID, and there are any number of RAIDs, 1 through 6 or 10, redundant array of independent disks, RAID. And so it's a way of backing up your data to make sure you have the availability that you need. The type of RAID that you choose will partly depend on your business need and your cost function. So it's total cost of ownership that you're applying. Solid state is a super great way, but very expensive way, to store data. It stores data on memory chips, and it uses less power. It's faster data access. There are no moving parts. It looks like your hard drive, but your hard drive has moving parts. A solid disk SSD drive has no moving parts. Great if you can afford it. There are other ways. There's magnetic storage, which uses tapes or disk devices. So magnetic tape is a type of secondary storage medium that we use, and it's frequently used for storing backups of critical data that you would need in the event of a disaster. And so this is how my company stores data, with a third-party organization that specializes in that. So you're looking at figure 4.3 here, which shows how the National Center for Atmospheric Research uses robotic tape backup to back up or cross-check their data of their fleet of supercomputers that are solving some of the world's most computationally intensive climate modeling problems. So I think that's very exciting. Like I said, there are lots of forms. I just wanted to touch on the topics themselves. Now we move then to input-output devices. So input-out devices is a way of getting systems on or off the computer, right? An input often requires transferring a human readable data into some form that the computer can use. So data entry and input devices come in many forms, and they range from special purpose devices that capture specific types of data to more general input devices. And so the topic is extensive. There are optical character readers, there's your keyboard and computer mouse. These are input devices. Even barcode scanners at the supermarket. Sometimes there are even laser scanners along the way. So optical character recognition is one of those great, and optical mark recognition as well. Just ways to get input into the computer that will go into memory and get processed by the CPU along the way. Okay, so what else did I want to say? Yeah, the barcode scanner is going to employ a laser scanner quite often to read a barcode label, and again, it passes that data to the computer. Okay, I think I'll stop there. Here's a picture of input devices, several of them. You have this keyboard, you have the stylus on the separate pad, you see the mouse over here on the right. Okay, RFID is something that interests me a lot. I hope it does you too. I think it is the future. We've actually been using RFID for probably about 25, 30 years now. It's radio frequency identification devices. So there's an RFID, or radio frequency identification device, that employs a microchip, a tiny microchip with an antenna. And what it's doing is it's broadcasting to receivers. So you'll need receivers. This would be great at supermarket checkout. If every one of our products had an RFID technology on the product, we could put stuff in our cart, go under a scanner, and if our credit card were already loaded, just walk out to our car. Wouldn't have to stop at all. It's very exciting. Cargo aerial ports use this to track cargo, for example, and it uses a special form of EEPROM memory. Of course, pen input devices are common. My Microsoft Surface uses one, and I love it. And touchscreens, Microsoft Surface as well. So here's just another example of your RFID tag. You see, they're cheap. They're cheap to make. They're quite easy. It's like a hotel room key card, right? And they're even smaller than that if you want them to be. Quite useful, and they're throwaway, right, when you're done. So you don't have to track them at that point. I think it's kind of exciting, and I love that kind of technology. It's changing our world. There's no doubt about it in my mind. Now, other output devices, how do I see the data? It gets put on my screen, right? I'll need a graphics card on my computer. And if you refer back to that motherboard lesson, you'll see slots for graphics cards, right? And this is important, that I have the right graphics card to support the output that I want. Printers and plotters, 3D printers, also good output devices. More on that in the readings in the material, and you can find other stuff online. Here's a picture of a 3D printer. I think it's kind of cool. I have a friend who does 3D printing themselves, and it's pretty neat. Okay, so moving then to computer system classes, right? So in general, computers can be classified as either special purpose or general purpose. A special purpose computer are going to be those that are used for limited applications. Maybe the CIA is using them, or NASA. Most of us are using general purpose computers used for any variety of applications, including business applications that we would use at work or in college, right, for example. Your portable computer is a general purpose computer. There are non-portable computers that can be used for one person at a time, etc. Right? The list can go on. They're mentioned here. There we go. Small enough. Portable computer is small enough to carry. It's easy. Examples include your smartphone and laptops, etc. So, and speaking of smartphones as a personal computer, in fact, let me jump to this figure here, right? This illustrates how smartphones employ a combination of chipsets, and this is called system on a chip, right? And this includes your core processor, the core processor that we talked about earlier. It includes RAM, that random access memory, that volatile memory that we talked about, and ROM, that read-only memory, right? Like your BIOS might have as your computer boots up. It might have some interface controllers and voltage regulators, is how this would work. So with system on a chip, all the critical components of the smartphone are confined in this relatively small area, making the device faster, more energy efficient, and reducing assembly costs along the way. So I think that's pretty cool as well. Technically and traditionally, the difference between, on this topic of portable computers, the difference between a laptop, a notebook, and an ultrabook computer was really just a matter of size and weight historically. And technologically, the advances have resulted in much smaller, lighter components in size and weight, that there's really no longer any big significance between them in my view. So there are non-portable single-use user computers. A thin client and a desktop are two types of those, as well as a net-top computer or a workstation itself, which is more powerful. Sometimes we refer to the workstation generally at work. Might be something in a SOC center, operations center, that people use. Very powerful, more powerful than a normal computer. Okay, on top of that, we have servers, mainframes, and other computers, and supercomputers. Okay, so picking it up with servers, mainframes, and supercomputers, really these are designed to support multiple work groups from various different departments. So they're really just a computer on steroids, right? To support tens of thousands even of employees, for example. So a server is, as I said, just a computer, but it's employed by a means to perform a specific task, such as running the network or internet applications or doing security on a network, for example. And so there are features there that make it suitable. It has its own special operating system, a server operating system. It has greater memory, greater storage capacity. It's faster and more efficient. It costs money, which is why we don't do it to all computers along the way, right? And an enterprise server, it stores and processes information and programs that the organization needs along the way. So it's really kind of neat, and it offers scalability. Servers in the cloud have even increased that scalability that is provided. So there are types of computers. One is the mainframe. A mainframe is a large, very powerful computer, and it's shared by dozens or even hundreds of current users connected to the machine over a network. Mainframes can support thousands of users at the same time, which is pretty exciting. And the key the key feature of a mainframe is backward compatibility, or the ability of the current mainframe to run software created decades ago. That's really very exciting. And then, of course, supercomputers are also exciting. This has the fastest processing speed, the highest possible performance out there. Based on the recent architecture, it'll employ a GPU, a graphics processing unit, in addition to the traditional CPUs, or central processing unit. And the speeds of supercomputers aren't in terms of gigahertz. They're measured in terms of petaflops, which is 1 × 10⁻15 power floating point operations per second, or flops. So that's pretty exciting, if you ask me. Okay, so that's a little bit about that. Now let me point out, here are some servers, mainframes, and supercomputers, the comparisons of speed, where they're deployed, etc. Kind of exciting. Okay, quantum computers. This is the next best thing going. And that quantum computers are the future, both for hackers and for infrastructure personnel. It is phenomenal speed, but that speed can also be used to hack into computers by running a cycle of sample passwords, for example. So there's a challenge ahead of us, but there is also an exciting future. Then we have data centers, right? We want to make sure they're climate controlled, have the right equipment in them. And we run tier 1 through 4 data centers. And notice you want to check fault tolerance, data usage, and power, etc. So that wraps it up. We'll come back with green computing next. Just touch on green computing real quick. It is environmentally friendly, uses less power than other computing centers. So this is a science in and of itself, to figure out how to do computing more cheaply. And this is